Daniel, what would you say is the... Daniel, what would you say is the most powerful force in the musical world?
Powerful force, eh? A tritone.
A tritone. I can prove this to you, but all the rest of intervals pale in comparison to a tritone. A tritone is far more dissonant. Let me prove it to you. You know the circle of fifths? We start with C on top, and then we go G, D, A, E, B, F sharp, C sharp, or D flat. The F sharp, if you look at that chart, that F sharp is directly opposite the C. It's as far away as you can get in the circle of fifths. Then you start to get closer again. Look at the notes that are on each side of that F sharp. It's a B and then a C sharp. See, we're just half a step away from a C. So a half step is very dissonant, but it's not the most dissonant. The most dissonant is that tritone. Do you remember the whole conflict that the medieval theorists had with the tritone? It is the reason that we have accidentals in music. It's the reason that we have key signatures, because we kept trying to fix the tritone. That scale degree 7 and 4 just always seemed to create a problem for us. Right? It's the tritone that was known as the devil's interval. Let's just go ahead and illustrate this now. We can create lots of chords based on a 1, 2, 3, 4, 5, 6. All those have a perfect fifth between the root and the fifth. Listen to that. Now it has kind of a hollow sound. Now listen. That tritone is really noticeable compared to just a perfect fifth. What's more, when I then create a 7th chord, a 1 chord, and a 4 chord, those are both major 7ths, meaning it's a major 3rd and a major 7th.
2 stacked perfect fifths.
But if you look at it a different way, it's 2 stacked perfect fifths. Look, C to G, B to E. Minor 7ths also are 2, 3, and 6. 2, 3, and 6. That
same thing.
But they are also stacked perfect fifths. There aren't any tritones in those chords. So you might say diatonic 7th chords, 1, 2, 3, 4, and 6, don't have tritones in them, and so they're sort of equally nice.
Stacked fifths like this.
Stacked fifths. Listen to the difference now when I play a 5 chord, 5/7 chord. G to D is a perfect fifth.
Perfect fifth.
And then there's the B to F. Boom.
Oh, that does...
We might say there are 2 different kinds of chords in the world. There are chords without tritones, and there are chords with tritones. So when we're looking to have more bite in a chord, one of the ways that we might do that is say, I'm starting with this minor chord, and I want it to have more bite. Let me put a minor 2nd in it. All right, that's got some bite to it. It's got a lot of bite to it, but compared to a tritone, hardly any. Now, there are some genres that use tritones in chords all the time. Jazz, in particular blues. So I play a 1 chord, C, E, G. I always just put that B flat into it. Notice the E to B flat.
Little tritone actually.
When I use a 4 chord,
keeps the piece moving. You can't just stay on that chord.
I want to prove to you in one more way that tritones are the most powerful interval
in music.
There was a man named Howard Hanson, well-respected music theorist and composer, and he came up with a way of measuring phatness in a chord so that we could understand music in some way. Okay, it's called chemical analysis. You can look on the chart and see what this is. There is a order in which we put the letters to analyze. and it's PMNSDT. Just learn it like it's a word. PMNSDT.
PMNSDT.
We're compressing all of the intervals to as small as they can go. So if you have a sixth, you make it a third. If it was a major sixth, it becomes a minor third, and so forth and so on. So everything gets compressed to an augmented fourth or less. The P is for perfect fourth.
Perfect.
Of all the intervals that are anything other than a unison, the perfect fourth is the most consonant. The next most consonant is a major third. That's the M. The next most consonant is a minor third. It's an N. The next most consonant is a major second. It's S for second. Then we get more dissonant, and it's a minor second. Boy, that really sounds dissonant, doesn't it? Well, that's the D because S has already been taken. Anyway, so PMNSD, what do you suppose the T is?
Tritone. The most powerful.
Now, to me, when I listen to that, I say, I can hear how those are getting more dissonant all the time. I can't imagine anything more dissonant than this. And though this is more spacious, it really is more dissonant. All right? So what we're going to do is take a chord and assign a numerical value. Now, Hanson didn't do this. This is the Reed version of Hanson Chemical analysis, because I like to put numbers on things. Okay, so we're gonna say a P is worth 1 point of fatness. Okay, and M is 2 points of fatness. 3 goes to N, 4 goes to S, 5 goes to D, and 6 goes to T. Now I'm going to demonstrate. There are chords that have tritones in them and chords that don't. And the ones with tritones are much more dissonant than the ones without. Here we go. Take a major chord, add up the intervals. You got a major third, a perfect fifth, and a minor third. Add up those numbers. Take a look over on the right. You see the total is 6. Fatness quotient of 6 for a major triad. How about a minor triad? Actually, it's the same.
The same.
It's still a 6. All right, you can look and see. It's still got a minor third, major third, and a perfect fifth, which we would call a perfect fourth. Look at a C, 2 no 3.
2 no 3.
You know what? It's the same. It's the same. Major second, a perfect fourth, and another perfect fourth. It still adds up to 6. So these then are equally fat.
Or really unfat, because 6 is not a very big number.
Not a very big number, okay. Anyway, all those are, can you hear how they're kind of all in the same ballpark? All right. If we were to put a tritone into that same thing. All right, we've got a tritone. That's a 6. We have a perfect fifth. That's 1 more.
Yeah.
That makes 7. And then we have a minor second.
Ooh,
which is 5 more.
So then we have 12.
We've got 12 compared to 6. Listen, 12, 6, 6, 6, 6, 12, 6, 6, 6, 12. Wow. Really makes a difference if you have a tritone. That tritone, yeah, I mean, just think about it.
Changes everything, really.
Root, third, and fifth with 3 notes. I add up to 6. I just have 2 notes. That's already a fatness of 6 with just 2 notes. That's nigh unto being miraculous. That is so powerful.
Yeah, definitely nigh.
Fat. Yes. So, if you want to really add fatness to a chord, add a tritone in there. So tritones, handle with care.